Bubble sort is a sorting technique that can be used to sort a given array or list of numbers. Each time when the iteration is done, the bigger elements are bubbled up to the right side of the list. So in this way we keep on getting the bigger elements and the sorted elements at the right side of the array. So this is the fact from which the sorting technique bubble sort has got its name. Right now what you can see on the screen is an example of bubble sort. The bigger element is 8, so it is being shifted to the right side of the list or the array. Here we go. Bubble sort works by repeatedly stepping through the array and comparing each pair of adjacent items and swapping them if they are in a wrong order. The pass through the array is repeated until no swaps are needed. That indicates that the array is sorted. And the bubble sort is used for small arrays and lists. In case of big arrays or lists, we would prefer a different sorting technique because the time complexity of bubble sort is not the best among its peer variants. Now let's talk about the sorting activities which are involved in bubble sort. So in the sorting activity of a bubble sort, we shall be having multiple passes through the array, and inside each pass we shall be comparing the two adjacent elements with each other, and if they are in a wrong order we shall be exchanging them. So in this way we shall be bubbling up the bigger element to the right side to its exact position, and by repeating this process we shall be getting a sorted array at last. So this will eventually result in a sorted array, and this sorted array could be in an ascending or descending order depending on the type of algorithm that you have used. Now I would like to demonstrate the working of bubble sort. You will be actually able to see what is happening inside a bubble sort. So suppose if you are given an array that is A in this case, and it is having 5 elements, and you have to sort it using bubble sort. So we shall start with the first two elements, we shall compare them and move the bigger element to the right side. Again we shall be having the next two adjacent elements and we shall be comparing them and move the bigger element to the right side. Again we are having next two elements and comparing them and move the bigger element to the right side, and so on. So at last what we get is the biggest element shifted to the very right side. Now suppose if there is a sorted array at the right side of this array, so right now what we have at right side is 5, and let's consider it to be a part of the sorted array. Now we shall again follow the same procedure which we had followed previously, so we shall again start with the first two elements and we shall compare them and move the bigger element to the right side, and so on. So at last what we shall get is the biggest element among the other elements that will be shifted to the right side of the array. So now we have two elements that are the part of this sorted array. So again what we have is that there are three elements in the left side of the array. Now we shall again follow the same procedure and we shall again compare them and move the bigger element to the right side, and again what we have are three elements inside the sorted array, and again we shall follow the same procedure and move the bigger element to the right side, and again we shall get four elements in the array that is sorted. So at last what we have got is one element that is left inside the unsorted array, and it will be considered to be sorted, so that will become the part of the sorted array. So this is how the bubble sort works. So this was the case of an array that is having a limited size equals to 5. But what if we generalize this array? Now suppose if you are given an n-sized array and now we have to apply the bubble sort on it. So if we count the number of comparisons which we do during the sorting period, it will be like n minus 1 plus n minus 2 plus n minus 3 and so on, and we shall end up at plus 3 plus 2 and plus 1. So it will produce a series, and when we add them we shall get n into n minus 1 divided by 2, that will be simplified into n squared divided by 2 minus n by 2. Now let's talk about the various time complexities associated with an algorithm. See, there are three kinds of time complexities associated with an algorithm, and they are best case time complexity, worst case time complexity, and average case time complexity. As far as the best case time complexity is concerned, it is the scenario under which the algorithm has to do the least amount of work. When we talk about the worst case time complexity, it is the scenario under which the algorithm has to do the maximum amount of work. And when we talk about the average case time complexity, it is between the best case and the worst case. And in the average case time complexity, it is the scenario under which the algorithm has to do the average amount of work. Now let's have a look on the algorithm for bubble sort. Suppose if we are given an array that is A and the size of the array is n. So an algorithm for bubble sort can be like this one. In this algorithm which I have created over here, you can see there are two parameters. The first parameter is the array itself, and the second parameter, which is this, is the size of the array. And inside the algorithm we are having two loops. The first loop is showing the number of passes, and the second loop, which is this one, is showing the number of comparisons we have to make inside each pass. And inside the inner loop we are having an if statement, that is this one, and this will be checking for two elements. If the element which is coming before an element is bigger than it, then it will be swapping them, and this function will be going to perform that task. It can be a sequence of instruction as well. I am writing swap over here, it means it is going to perform a swapping over here. We can use multiple statements, or we can use an additional temporary variable over here as well to perform the swapping process. Now let's have a look upon the C++ function for bubble sort. So according to the algorithm which we had seen just now, we are going to create a C++ function that will perform the bubble sort. So this can be a C++ function that can be used to perform bubble sort. So the name of the function which I have chosen is bubble sort, and this function is taking two parameters. The first parameter is the array itself, and the second parameter is the size of the array. And inside this function I am having a temporary variable, that is t, that will be used inside the swapping process. After this we are having two loops. The first loop will be used for passes that we have to make, and the second loop will be used for number of comparisons that we have to make inside each pass. So inside this loop what we are having is the if statement that will be checking for two different elements, that the element which is coming before an element, if it is greater than the next element, that it will be swapping those two elements using the temporary variable t, and this will be the code that will be swapping those two elements. So this one will be the code that will be used for swapping process. So inside this one, what we are having is a temporary variable. First we shall assign the value of ai to the temporary variable t, and after this we shall be assigning the value of ai plus 1 into ai, and now what we can do is that we can assign the temporary variables value into ai plus 1. So in this way these two values will be swapped with each other. Now if you will keenly observe this function which I have written over here, you will find it inadequate. Why am I saying this? Is because of the fact, suppose if we are given a sorted array, so in that case also the outer loop that you are able to see right here will be running for n minus 1 times, but it no longer have to run for that much time, because if we are given a sorted array, this loop will be running for n minus 1 times, and this will be checking for the adjacent elements, and if no swaps are done, then it will indicate that the array is already sorted. So in that case we must stop iterations. So we must need some kind of enhancement that are to be made inside this function so that it will stop in case of sorted array. So it will stop iterations if it will find that the array is already sorted. So we need some kind of smart work over here, so I'm going to enhance this function, and then it will be working smartly. Now to enhance this C++ function which we had seen, there can be a huge number of techniques, but the technique which I'm going to use over here is that I'm going to use an additional variable that will be sensing the swapping process. Suppose inside each pass, if no swaps are done, then it will mean that the array is already sorted. Suppose if I enter inside one pass and no swaps are done, so it will indirectly mean that the array is sorted, that's why the swaps are not done. So I'm going to use that swapping process, so I shall be putting an additional variable inside that swapping process. If any swapping process is done, then it will mean that the array is not sorted, and if it is not done inside one pass, then it will mean that the array is already sorted, and we have to stop further iterations. So this is the enhanced form of the bubble sort function which we had seen previously. So I'm going to use an additional variable that is sorted over here. I have set its value to 1 initially. That will mean that the array is sorted. After entering the first loop, I'm going to assign the value of a sorted variable to 1. That will mean that array is sorted. So it will assume that the array is already sorted, and after this we shall be entering the inner loop, and inside the loop we are going to have multiple comparisons, and if any kind of swap is needed, then it will return the value of a sorted variable to 0, and in case if no swaps are done, then it will keep the value of a sorted variable to 1. That will mean that the array is already sorted. So in that case I'm going to break further iterations that are going to be performed in near future. So this will increase the proficiency, as well as it will reduce the time for you know, performing bubble sort. So it will be the enhanced form of bubble sort. Now let's calculate the best case time complexity for bubble sort. Suppose if we are given an already sorted array, so in that case we shall have to put less effort to sort this array. So in that case, the outer loop that you can see over here will be running for once, and the inner loop, that is this one, will be running for a time equal to n minus 1, or it will be running for n minus 1 times. And if we consider that this if statement is taking a time, a constant time that is equal to c, suppose, then the overall time that will be required to run to the completion will be c into n minus 1, because the if statement is taking a time equal to c, that is constant, and this loop will be running for n minus 1 times. So overall, if we calculate the time in totality, it will be c into n minus 1. So if we are given an already sorted array, then it will be like a best case for us. So in that case, if we are given a sorted array, then the time that is required to run to the completion will be dependent on c into n minus 1, where c is the constant time required for if statement, and n minus 1 is the number of times the inner loop will run. And if we neglect the constant c from here, then we will be left with only n minus 1. Now for bigger values of n, the expression will only depend on the value of n. So by the definition of big O, if we suppose that there is a function gn equal to n, and there's a function that is fn that is equal to n minus 1, then in this case, if we suppose that there is a constant c1 that is equal to 1, then for all values of n, the expression c1 into gn is always greater than or equal to fn is satisfied. Hence we can say that the complexity of bubble sort in best case can be denoted by order of g of n, or in this case it will be order of n or big O of n. Hence the time complexity of bubble sort in best case will be order of n or big O of n. Now let's calculate the worst case time complexity for bubble sort. Suppose if we are given a reversely sorted array, or suppose if we want to sort an array in ascending order and the given array is in descending order, or vice versa. So in that case we shall have to put maximum amount of effort, or in that case we shall have to use this function to its maximum extent. Now suppose if the statements that are there inside this for loop are taking a constant time equal to say c, and these loops are taking a time equal to say these loops are taking a time equal to n minus 1 plus n minus 2 and so on till 3, 2 and 1, because the first time, at the very first time, the loop will be running for n minus 1 time, the second time it will be running for n minus 2 times, and so on, and at last it will be running for n minus k minus 1 time. So if we combine, or if we add all those values, and then we shall get an expression like this one. So these loops are running for this much time as a whole, and these statements are taking a time equal to c. So the overall time that is required to run to the completion in worst case will be c into n minus 1 plus n minus 2 plus n minus 3 and so on till 3, 2 and 1, or till n minus 1. So this will be the overall time for worst case. So if we are given a reversely sorted array, then it will be like the worst case for us. So in that case we shall have to put maximum amount of effort to get the array sorted. So in that case the time that is required to run to the completion will be dependent on c into n minus 1 plus n minus 2 and so on till n minus 1, and it can also be written like this one. So in this case the c is the time that is required by the inner statement that are there inside the inner loop, and if we neglect the time that is c, then we shall be left with this one, that this expression, and if we simplify this series, then it will be like n into I minus 1 divided by 2, and it will be further simplified into n squared divided by 2 minus n by 2. So for bigger values of n, the dominating term will be n square over here. So by definition of big O, we can assume a function that is gn that will be equal to n square, and in this case our fn, that is the function, will be equal to n square divided by 2 minus n by 2. And if we suppose that there is a constant that is c1 that is equal to 1, so for all values of n, the value of n square will always be greater than this expression, that is n square divided by 2 minus n by 2. So this will be satisfying the condition that is required for big O. So this is satisfying the condition that is c1 into gn greater than or equal to fn. So the time complexity of bubble sort in worst case will be dependent on n square. So the time complexity of bubble sort in worst case will be order of g of n, or it will be order of n square in this case. Now let's analyze the average case for bubble sort. Suppose if the given array is partially sorted, so it will be like an average case for us. So if we try to calculate the time complexity of bubble sort in average case, we can calculate it by adding the complexities that were calculated under best case and worst case and dividing it by 2. So what we shall get is cn plus cn square divided by 2, and it will be proportional to cn square. If we are talking about the larger values of n, then the cn square will be the dominating term. So the time complexity in average case for bubble sort can be given by order of n square, or big O of n square, where order of n square is called quadratic time. Now let's calculate the space complexity of bubble sort. As far as the space complexity is concerned, it is the combination of the constant memory space as well as the auxiliary memory space. The auxiliary memory space is the memory space that is allocated later at runtime. So if we try to create an equation for space complexity, it will be like sp equals to c plus sp, where c is the constant memory space and sp is the auxiliary space that is allocated later. Now in bubble sort, the memory space allocated to the array elements and to all the temporary variables which we had used previously is considered to be the constant memory space, and that will be c in this case. Further, the program will take a constant space in addition to c irrespective of the array size. Now let's call it sp over here. The constant memory space that we have calculated here is generally not considered for the calculation of space complexity for an algorithm. So if we neglect C and consider only SP for the calculation of space complexity of bubble sort, then what we shall get will be the space complexity of bubble sort, and that will be equal to the order of 1 or big O of 1. So now since we have calculated the time complexity and space complexity of bubble sort, let's have a quick recap. So we had previously seen that the time complexity of bubble sort in worst case will be equal to order of n square or big O of n square. In average case it will be equal to order of n square or big O of n square. In base case, the time complexity of bubble sort will be order of n or big O of n. As far as the space complexity is concerned, we had calculated it to be order of 1 or big O of 1. So this was a tutorial on introduction to algorithms and bubble sort. If you have any query regarding any section of this tutorial, you can feel free to contact me on my email ID, that is gauravparmar@gmail.com. I have been working as a web developer since last 1 year, and I have good knowledge about PHP based website development, so you can contact me for that as well on LinkedIn profile. And also you can follow me on Twitter. And do check my tech blog, that is Being Technical. I usually write about tech stuff there. You can also connect with me on Facebook, and at last do like this video and subscribe on my YouTube channel. Thanks for watching this video. See you next time.